I have to start this interview by saying I hate wearing shirts this color, and I've sworn never to do it on video because no, I like this color. But if you look at the room behind me, it's all brown. And then when I wear a brown shirt, I fade into the background. But I'm making an exception today because I literally 5 minutes before this interview, I went to my closet and I was like, what am I going to,
You
I
got to
just
get the
grabbed the
shirt.
shirt.
Where is it?
No, but that's the thing. I just reached in and I was like, what shirt am I going to wear? And then I was like, it has to be this shirt. I was like, because this is the linchpin. Oh, you can't see it. This is the linchpin. This is the original sort of inspiration that Terrence Howard, or we call him Terry. He prefers to be called Terry. Does he ask you to call him Terry?
Yeah, I just call him Terry.
Terry. Everybody calls him Terry when you know him. This is the original design that he's come up with. This concept, this collapsed dodecahedron, and he said, "I want people to make a multi-rotor in this shape." And he put up, I think it was $25,000 prize. Is that right, Kevin?
Yeah.
And
started out as like 15,000. You raised it to 25,000 for first place.
yeah. And the reason we're talking to you today is that you won that prize.
Yeah.
Yeah, you won the prize. You developed a multi-rotor that looks like this. We'll put some of your stock footage up, and so people don't have to stare at my shirt. And having done that, I wanted to get a little interview with you to talk about the whole process. And so welcome Kevin Plaisir to the interview.
Yeah, it's good to be here.
And I always like to start because maybe many people may not know you by name, but they may know your project, the Emuflight project. You're the lead developer for Emuflight. So it's not like you came out of nowhere when you said, hey, I'm going to write some flight control firmware. But I imagine this was very different from a lot of what you've done in your work with Emuflight.
Yeah, in some regards, yeah. Got me looking at different pieces of code that hadn't really delved much into.
Yeah. So what were some of the challenges? What were some of the ways that making the linchpin, as Terry likes to call it, was it different than just making like a quadcopter fly?
Yeah, well, I mean, making a quadcopter fly, it might sound like a crazy feat, but it's actually fairly simple, right? We get our PIDs, which PID controllers are used everywhere. They're not too difficult. And then you get a mixer and you say, when roll PID does something, move, the front right motor a certain way. And when pitch does something, move it a different way. And when yaw gives me a command to do something, and you set that up for every motor, and it's just the, dynamics of your system with your motors, and you just send it and it flies. And that's not entirely that tricky. Lots of people have done it. There's all the toy drones. There's, it's a fairly simple problem. But the linchpin, it's getting that crazy shape to rotate any direction and still hover and be able to translate and do anything in any orientation. So it's a much more complex system that you have going on.
Yeah, I think one of the things that makes the linchpin stand out is with a standard quadcopter, up is always up, not relative to gravity. I mean, it can flip upside down, but it up is always up, and the right side motors will always make it rotate to the right and left and so on. And the linchpin, one of the requirements that Terry had was that it be able to rotate and pivot in space into any orientation. So the mixer can't assume that like this motor is always going to be pushing the up, or I guess it can assume that it's always going to rotate it a certain way. But if you need to hover in place, the motors that you spin to make it hover in place are going to change depending on how it's oriented.
Yeah.
Talk a little bit about that. How did you approach solving that problem?
So, the big thing there is you have to know where the drone is in relation to the world, right? If you don't have that perspective, then you don't know if you're upside down, right side up, left, right, whatever. And we have that in, our software as our roll, pitch, and yaw.
Okay.
There is a problem though to roll, pitch, and yaw. Those are called Euler angles, and they run into problems at certain angles. And that happens to be plus or minus 90 degrees pitch. You run into a singularity, or They also call it gimbal lock. That's another term for it. But if you can, like anyone can test this, you just grab your drone and you look in the GUI, Betaflight, Emuflight, whatever, pitch your drone 90 degrees and look at what the roll angle does. It'll be maybe like 10 degrees roll, and then very quickly like 180 degrees.
And I think what you're getting at is you're talking about the angle of the drone relative to the horizon, that sort of as you approach 90 degrees pitch forward, the roll axis is essentially non-existent relative to gravity. Obviously, relative to the quadcopter's frame of reference, roll is still roll and always is. But if you're talking about relative to the horizon, once you pitch forward, there is no more roll axis. In fact, the yaw axis has become the roll axis.
So you got to account for that. And there's something. It's kind of in the code. We don't use it a crazy amount. We have some quaternions in the code, and quaternions are a 4D representation of 3D space. So, it even uses imaginary numbers. So it's really weird stuff you're doing, but you're able to get around that issue of the gimbal lock and those sorts of issues. So you can get a more true view of where the craft is at. Not that the Euler angles, the 3D picture is wrong. It's just not, there's certain places where it breaks. So you got to use this more complicated 4-dimensional math to represent 3D.
I'm sure Terry loved hearing about that. He's big on dimensions and so forth. When this project was first proposed, there were people who said this is preposterously difficult. $25,000 is an insultingly small number. No one could do it. It's going to take years. There were people who felt it was very difficult. And I thought, of course, I'm an idiot in this sense, but I thought, well, the mixer, it seems like the mixer isn't that complicated. You just rotate the mixer like with a matrix rotation about which direction the motors are thrusting based on the quadcopter or the multi-rotor's orientation. Seems like the mixer isn't that complicated. Was it complicated, or was it just sort of taking the standard mixer and rotating it as the craft rotated?
Yeah. So there's lots of different ways you could approach it, but with some of those Euler problems and other things I ran into, dealing with quaternions instead of Eulers, some of that like just matrix rotation stuff, I decided to not actually do some of that, and instead there's a quaternion number I can get that basically tells me how right up I am.
Oh, interesting.
And the code actually uses it. It's in Betaflight and Emuflight. It tells it how right side up it is. And if you're perfectly flat, you get a 1. You're all the way upside down, you get 0. And you get -1. And here 0.
Makes sense.
That's 0, and this is -1. And so using that, I can easily vary the thrust of my motors. I can say, I have to find out what the motor's worldview is. So how flat is this motor?
Right.
But then I can feed it those numbers and say, it's flat, it's pointed up, so give it thrust. Or is it upside down? Tell it to quit spinning. Or is it 90 degrees, so thrust shouldn't affect the motor, just the roll, pitch, and yaw stabilization.
Yeah.
So doing that with the code, I could have a static mixer that just tells the drone how it's going to fly, just like any other drone, and then just vary the thrust.
So essentially that number, basically just you feed that number into the mixer, and it has the effect of compensating for the motor's rotation away from flat and level.
Yeah, so you just feed that into your throttle command that makes it into the mixer.
Right.
And so for each motor, you say, how flat is it? If you're perfectly flat, then you want to feed it all the throttle.
Right.
Upside down, you actually want to reduce thrust on the motor. You don't want it to pull down. So give it negative thrust or take away thrust. And maybe use it for stabilization in extreme cases, if thrust is 0 and you're doing a crazy flip. But sideways, you have 0. You don't worry about your thrust, just stabilization.
Now on our quadcopter, it is usually the case that all 4 of the motors are flat and thrusting in the same direction. There are some exceptions to that, like a V-tail, but generally that's true. But on this Lynchpin, the motors are facing all different direction, and in fact, at no point do you just have a flat plane. The motors are always angled. So I imagine that the mixer got a lot more complicated in sort of knowing which direction the motors were pushing, and then how that would cause the quad to, because like if you just want to do a flat hover, you're going to have to balance the thrust from like 3 different motors.
Well, I mean, some of what's nice is you don't really have to worry about the individual thrust from motors, just the total thrust. As long as the total thrust is pointing down, you might have some thrust going out this way, but they cancel.
Sure.
And so you just worry about your total thrust. And so you have your you look at it from a physics perspective, the only thrust you have is straight down. That's your thrust vector, straight down.
Right.
And as long as it's straight down, which you're getting through the way I mixed throttle into everything, you just get it straight down, then you don't have to worry about, what happens when you rotate, because your thrust still points down.
Yeah. Now you went with an interesting approach here. One of the challenges that was discussed that was going to be difficult to solve was canceling yaw. And a lot of people who fly quadcopters know that you always have 2 clockwise spinning motors and 2 counterclockwise spinning motors, so that the net torque of the motors cancels out, and the quadcopter then can be made to yaw or not yaw. But because of the way these motors are oriented on the faces of the Lynchpin, canceling out yaw is especially challenging, right? Is that right?
Yeah, I mean, if you've seen my Lynchpin, it's got 12 motors, and if you look at the Lynchpin website, it shows you what way they want the motors to spin. And so I did that, and I have 12 props all spinning. I can't remember if it's clockwise or counterclockwise, but all the motors are spinning the same way. So the addition of all the motors makes it always want to spin.
Right.
So with the shape you have, in certain orientations, if you're hovering it, you have 3 motors kind of at angles like this, and then you have 3 that are
right,
vertical, and those 3 that are vertical, they're just always counteracting some of that yaw.
Now, I'm surprised to hear you say that, because I would have assumed that the way to approach this was so you have 12 motors, 6 coaxial. They're each 2 motors are coaxial, and then on 6 planes you have 12 motors. Mm-hmm. I would assume that the way to approach this is to have each coaxial pair of motors counter rotating, and that would result in net 0 yaw. But that is not how you approached it. I'm surprised to hear that.
And doing it the way you're saying still wouldn't result in net 0 yaw, because the motor you have facing up, it's at like full throttle potentially, and
sure,
not doing anything. So you still get that yaw effect. And so
right,
on his website, the customer's always right, looking at his website, seeing, here's the way he wants it. All right,
wow,
motor's spinning the same way.
Yeah, because on a quadcopter, you can always assume that the diagonally opposing motors will spin at the same at a speed so as to allow to create a net 0 torque, because the motors are coplanar. But on this thing, you've got some motors that are spinning much faster, and so you're actually canceling the yaw with thrust, not just with the torque of the motor.
And so I actually modified some of the yaw code, because in Emuflight we treat yaw differently than pitch and roll, just because pitch and roll is based on thrust. Mm-hmm. It's just if you look at your logs, you do a quick flip, it's just a burst of thrust from 2 motors, and then you're just rotating. The motors basically go to idle. You stop the flip and 2 more motors kick in. But with yaw, you have a constant throttle, because it's the torque from the yaw motors and the way they grab the air that rotates it, not the thrust they make. And so in Emuflight, we deal with yaw a bit differently, but I got rid of some of that, because now that it's a thrust-based yaw, I want it to react the same as pitch and roll.
Sure. Well, it's somewhat thrust-based, but you're still getting yaw moment from the torque of the motors, right?
Yeah, it's the torque of the motors and kind of the way that the props grip the air.
Right.
As they're rotating. If you could create thrust without rotating anything, then you wouldn't get any.
Right.
So that the way it grips the air is part of it, and then just the change in the moments of inertia from speeding them up does it as well. And in this craft, it's not doing that, It's just a whole thrust-based yaw.
Yeah. Now, some of the other competitors went with a solution where they had 6 motors and the motors would use basically 3D mode to reverse direction. And you were, I think, the only one who didn't do that. Surely you considered it. Why'd you go with 12 motors instead of doing reversible motors with only 6?
So, I mean, the real answer is that, the customer's always right. So I first built it and had 6 motors, had 3D props for them, had a bunch of the code written for 6 motors, because I do have to change a bit to do the 6 motor version versus 12. Had it, was getting it ready. I had the aircraft built, was about to start test flying it. And I got in a call with Terrence, and he's like 12 motors. And he mentioned it quite a few times and like, oh, we really want to see 12 motors. Like that'll be the person that like wins it. They'll be the one with 12 motors.
I got you.
And I'm like, okay.
Now, I don't think that was an official requirement like in the rules, but apparently you kind of read between the lines as to what he was looking for and decided that was the thing to do.
It's not like a rule, like you can do it without, 12, but you could tell Terry really wanted to see the 12. And so I'm like, okay, I can do that. And I had plans to build 2 linchpins and potentially like, try and do some bonding type stuff with it just manually or some other stuff.
Mm-hmm.
Didn't have the parts for that now that I was
right
12 motors, because I actually had to use, the stack on that's ridiculous. It's got 3 4-in-1 speed controllers and then my flight controller.
Yeah, what flight controller did you use that has 12 motor outputs?
The SP Racing H7 Extreme.
That was when I was thinking about this, I was like, is this even doable? And I was like, what flight controller? There was a time when I didn't think you'd be able to do it with 6 motors. I mean, what do I know? But I was clearly wrong. But I was like, is this doable? What flight controller out there has 12 motor outputs? That was the only one I could think of. I think now the Lumineer H7 has like 16 motor outputs or something. But
interesting, because that's if you look at the Emuflight or Betaflight code, by default, most motors they support is 8. So I have to modify code to allow support for more motors. CleanFlight does support 12, but who flies CleanFlight these days? So had to re-enable the 12 motor outputs to get it working. So that was, and I'm in contact with Dominic, the guy that makes it. So
yeah. Are you running D-Shot? 12 D-Shot outputs?
No, 12 multi-shots.
I got you. Because I was curious if there was enough timers and DMA channels for that.
I was trying D-Shot and I couldn't get it working. So multi-shot works. So
yeah, I mean, it does the job. I mean, I guess you're not going to be turtle moding that thing.
And you don't need to anyways. And multi-shot's a bit cleaner than D-Shot as well. And with the 3 stacks of speed controllers, that might help out a little bit.
So one of the requirements of this project was that it be able to rotate in place to any orientation and translate left, right, forward, back, up, down. And I couldn't think how you could do that on a standard controller. So you've got like 2 sticks, right? And that gives you pitch, roll, yaw, throttle. But what did you use for controls for the rotations?
You just need like multiple mode switches. So I'd have multiple modes I'd switch through when I'd fly. I'd have one mode it wouldn't do any of the throttle correction. So if I rotated 90 degrees, it would still just fly like a normal quad. Correct for that. So I'd have the normal standard orientation, then I'd have a switch and I'd flip it, and I called it the linchpin mode, where as I rotate it, it now accounts for my thrust. I rotate 90 degrees, I'm still hovering. And that
interesting.
It just rotates in place, and that's all I'd have there. And then I'd flip another switch, and that was translation mode. And in translation mode, I had 2 knobs on my radio, and those knobs pitch and roll.
Gotcha.
Then my right stick was just forward, back, left, right. Left stick was my throttle and yaw, and that's how it worked. So when I was translating, my pitch and roll was just separate, because it doesn't matter what angle I'm at when I'm just translating, because I can still forward and back whatever orientation it's in.
Yeah, right. That makes sense. Is there a mode where you can fly it kind of like an acro quad, where you pitch forward and it like pitches forward? I guess the motors don't really work that way, do they? Yeah,
that's the mode I'd take off in.
Oh, there was that.
Yeah, and then I could switch it. So if I wanted to, I could get it upside down and then go back to acro, and it would still hover upside down, but fly like it was acro. And you'd have to tilt it to go, and it wasn't just a translation thing. So really weird. Controlling it was tricky. I'd get confused. Like if you watch my video, you see the end. There's tons of crashes. A lot of that's just pilot error. Like I get confused as to what way
Yeah.
it anymore, and I just end up crashing it.
You know, one of the questions that people asked at the beginning of this project is, what's the point? And my response at the time was, I don't know. But if somebody wants to pay 25 grand to get someone to do it, and someone else wants to do it in exchange for 25 grand, hey, let's just figure it out. Having built it and flown it, what do you think? Do you think they're like, as you're talking about, oh, it really changed the way I think about flying. And I'm like, yeah, were there like insights, mind opening stuff, or was it just like, it's a project, I'm doing it? You see what I'm getting at?
But yeah, I mean, when I started, I was like, well, I saw all the negativity and everyone like, oh, it's a scam. You'd have to pay a team of engineers to get this done. It would take years, blah, 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 whatever. I heard all that. And I'm like, well, I think I can do it. And I want to show that I can do it,
Yeah.
I think it's as mind-blowingly difficult as people think. And I'd like to show like, hey, look at me, I did it. And then, hey,
Yeah.
who else thinks that they can do it? I could win a prize. Doesn't sound too shabby. So I originally signed up for that. But for instance, since doing the project, in Emuflight, I've implemented like some new code. Like I've called it Air Mode 2.0 because it restructures the way that air mode works, uses quaternions a bit more. It's kind of a weird quaternion Euler combination, but it's able to get like angle mode way smoother. And I was only able to come up with that after messing around with the Lynchpin and seeing those sorts of issues and then needing to fix them.
Yeah.
Just in like Emuflight code, I've come up with a few new little things you could do, and I still have more ideas that I might look at later. But then, it's a pretty neat project to see something like that. It's got 6 degrees of freedom. Normal multi-rotors are just 4 degrees of freedom. Pitch, roll, yaw, throttle. This has all 6. And, Terrence wants to see this do really big things, and, maybe it will one day. We'll just have to see. But
yeah,
if it does, I can, I was a part of that.
Well, I think I definitely I was gratified to see that you won. I don't really have a stake in your personal success, but I always like to see an underdog achieve and prove everybody wrong. And I feel like there have been people out there who said, that they would maybe poo-pooed the Emuflight project and said, well, you just maybe taking Betaflight and maybe making a couple little changes, and maybe not put a lot of faith into your chops as a programmer. And I feel like having accomplished this, I feel like your bona fides are unimpeachable at this point. Like you've done it, right? I feel like you really proved yourself. Not that maybe you needed to, but if you did, you did.
Yeah. In a sense, like I think a little bit of the motivation as well was, I've heard a lot of people, especially when Emuflight was starting, like giving it hate, saying it's just going to die like Butterflight did. It's just a waste of time, blah, blah, blah. It's just different defaults. You just like the logo. It's all placebo. And I'm over here like, I've changed all this code. I know what you're saying isn't right. And then, it's been like 2 years now since Emu started, and I'm still here. And it's like, in a way, it's like I want to just show those people as well that, I can do this. I'm not just some placebo man that's firmware and just thinks he's cool, but show that I can actually do some stuff with it as well.
I mean, there's no doubt that in order to build the Lynchpin and code the code that flies the Lynchpin, you couldn't just be like, oh, I'm just going to copy some stuff from over here and copy some stuff from over here. You had to invent something new. So that's congratulations on that. Yeah. What about the building? So it's one thing to write the code, but you had to literally build this thing. Like, how did you approach that?
Yeah, so I used CAD and just looked at the I never got sent the free Lynchpin, not the free, but the box Lynchpin, or the one from Race
Yeah.
Rotor Riot. There we go.
They sent out a model of the Lynchpin with some 3D printed parts in a quad box.
Yeah, and basically I just looked at that, went, yeah, that looks pretty good, and I just copied a lot of that. Used his website to find the correct angles for everything, made the corner pieces, and then just connected it all together with carbon fiber tubes. Added some little motor mounts and made the center section bigger so I could fit flight controllers and the speed controllers. And it's pretty much how I did that. And then I don't have a 3D printer, so I had a friend print it out. We originally didn't use TPU, but that just shattered on us.
Oh yeah, no, you gotta use TPU.
That's what I was telling him. He's like, it'll be fine. Yeah,
no,
it wasn't.
It'll explode.
TPU, that worked a lot better.
That's the way to go.
I still managed to rip the TPU, but it kept flying even when it was ripped, so I just kept sending it.
Yeah, nice.
Yeah, so just TPU, and just pretty similar to. I'm sure the size dimensions are different than the Rotor Riot one, but
yeah,
similar design to that.
Well, the Rotor Riot one was never designed to actually be flyable. It was just some little wooden skewers with little, whatever, 1/4-inch skewers or something with 3D printed mounts. I don't think you could have flown it.
Yeah, mine was fairly similar, with just like an extra bar going across it to mount a motor, and then
nice.
It mounted around the tube. Didn't even have to drill into the tubes.
Did you have any
downside as well? Because every time I'd crash, the motors would twist on me. And I'd have to put them back into place. And so every landing, I'm twisting it, making sure everything's lined up.
Did you have any particular problems with vibrations or resonance? Because it's a pretty weird design.
So I said all the corners were made from TPU. This thing flexed a lot.
Right.
Grab it and really just twist it. So I'd put it down and try to twist it just so it's the perfect Lynchpin shape. And I'm like, it's never going to be perfect, but it'll still fly. So you pin it up. I did some black box logging on it. It was ridiculously clean. And I was like, okay, dropping a bunch of filters, tune it a little.
Wait, why was it clean? How could it have been that clean if it was so floppy?
Well, it's just so much TPU dampening everything. And it's fairly you could grab it and twist it floppy, but you're never quite flying it really hard to where you're gonna shake it at those frequencies. And so the TPU is just dampening it enough that you never hit those low frequency wobbles from it. And so I never saw those problems. But just the gyro, I looked at the traces. It's I only had noise down to 50 hertz, and everything else was just empty.
Wow.
Okay, that's real interesting. But crashes, some of the arms would come out of the tubes. I'd have to shove them back in. And
I just did not even want to think about crashing that thing. Does not seem like a good time, I'll tell you.
Oh, you just get used to it. You just twist the motors again, shove the pieces back in, because none of it's glued. You just shove it back in, line it up fairly well, send it in the air again, test it more.
So you developed it. How long did it take you from sort of I'm going to do this to having a flying prototype? How long did it take?
Yeah. So I'm not sure, because when I heard about the competition, from what I heard, I was one of the first guys that signed up. I didn't start working on it immediately, but I was able to do a lot of the CAD stuff, probably December, get it built in January, and then life and school and everything, and I'm still working, so life's quite busy. And then it's the deadline's coming up sooner, and we're ready to go as a 6, with 6 motors. It's shoot, I got to change it to 12 motors now. And so I never flew the 6 motor version, but I had it pretty much ready to go. So I just scrapped that, went to 12. And the first time it went in the air was probably just a few weeks before competition was supposed to be done. And first flight, it just flew. So I was very surprised about that.
Yeah.
A lot of bench testing, let's make sure all the motors respond the way I'd kind of expect. But then stick the props on, it went up the first try. So that surprised me. But I was, I did a bit of a gamble deciding to redo a lot of it and go to 12, not having as much time.
Well, it paid off. I mean, that seems to be what tipped you over. Now, there were several other finalists who completed, and I want to point out that Terry voluntarily decided to give all the finalists the full $25,000 first prize. which was a really cool move on his part, and I just
Yeah.
want to point that out. But you were the official winner, so that really going to 12 motors seems to be what put you over the edge for whatever
Yeah,
reason.
yeah,
He
I
really
was the
liked
winner
that.
in Terry's book.
Right. Now
Yeah,
you're gonna keep working with him, right? It's not over, is it?
yeah. So like the rest of us that have won, like I'm still in contact with those guys. We're still doing things, and we're gonna try to push some cool things, and we'll see where it goes. I'm hoping for the best, but if it doesn't end up going anywhere, I'm still in a good position. But
Yeah.
we'll be working towards some cool stuff, and we'll see where it goes. But yeah, I've been in contact with the other finalists, the other winners, and
Yeah.
all cool guys. So none of us have any animosity towards each other. It's we're all cool with each other.
Yeah.
Nice.
Yeah. Well, that's fantastic. I really just want to, congratulate you on the win. And I look forward to what you're coming up with, going forward. But even if it just stops here, you've created a really cool thing. The first linchpin that I saw flying was Peter, Mr. I Am Pete's.
Yep.
And the first time I saw it flying and rotating, I was just like so awestruck. Because people were like, well, what's the point of this? What can it do? And at that moment, it didn't matter. It was just like, oh my God, I've never seen anything like this. And I think if that's all the contest created, I think there's something to be said for it.
Yeah, yeah. When I saw Peter's video, I was like, geez, that was fast.
Yeah. Oh, he was fast too.
I was like, I got to step up my game. Like, he made that really, like, it didn't take him long to build. I'm like,
No.
He spends the rest of the competition getting it better. Like, at that point, I was like, he's probably going to take everything. And I still want to finish it, show that I can. Like, I don't care if I win or not. But
I assumed he was going to win. He did it so fast.
Yeah.
And also on some level, I was like, how could you do it better? But, then 4 other people, including you, came out of the woodwork and did it. And I was like, well, damn. So it's really something. You're still working on Emuflight though, right?
Yeah. Emu all the time.
Awesome. Thank you so much, Kevin.
Yeah.
What should we link down below? Anything you want to plug?
Well, probably Terry's Lynchpin, and you could, if you want to pin Electrifly and Aguirre, I work there. We could pin
Awesome
Emuflight as well.
Yeah, for sure. If you have a Betaflight flight controller and you haven't tried Emuflight, it's easy to flash. Just do a config dump, save your config dump, flash Emuflight, set it up. Set up all your basic settings and give it a fly. See what you think.
Yeah, as long as it's an F4 or F7.
Right.
And we are looking at bringing back some F3 stuff just as like a draw for it. So
nice.
I don't know how many people that'll interest, but hey.
You never know. All right, Kevin, thanks so much.
Yep.
What are you doing in here? The least you could do is subscribe or join my Patreon or, just here's another video I picked out for you. Jeez.